In this video, we will discuss one of the easiest tests in statistics, the one-sample sign test. Sign test is a non-parametric test, and we will go into the definition in a second. But first, let me share why I enjoy teaching, learning, and applying the concepts of non-parametric statistics. The non-parametric test is easy to understand, very easy to compute, and it does not involve any population parameters. For example, all you do to compute the test statistics in a sign test is simply comparing the median in your hypothesis with the data over here that you already have. Number 2, the sign test is structured in that we simply follow some steps and then we are done with the test. The sign test saves my day, especially because it does not assume anything about the population distribution. Now, the normal distribution is not always appropriate to use, especially when the sample size is too small or the data has outliers, or if the data is not symmetrical. And this is what we normally experience in our reality, isn't it? In addition to continuous data, we could now conduct hypothesis tests for ordinal types of data. So what is ordinal data anyway? Ordinal data has some sort of rank or order into it. For example, in a questionnaire, you might ask to rate your level of happiness from 1, unhappy, to 5, very happy. Another example could be your satisfaction ratings from poor to excellent, or level of education from no education to a PhD. Those are examples of ordinal types of data. Let's recall what we have learned about hypothesis testing. So far, we have conducted parametric tests for one population mean or one group test, or hypothesis test for one group of data. We have also learned how to conduct hypothesis tests for two independent population means or for two groups of data. We have also learned ANOVA, which we use when we want to compare 3 or more groups of subjects. In the next videos, we will discuss the corresponding non-parametric tests for one group or sample, two independent groups or samples of data, and for 3 or more groups of data. We will start with the one sample sign test in this video. So the properties of the sign test is that it is a test for one population median, and this corresponds to our hypothesis test for one mean. When the sample size is greater or equals to 26, we will be using the normal approximation. We will start by determining the sample size. If the sample size is greater or equals to 26, we will be using the normal approximation. Otherwise, we will be using the standard sign test method. We start by stating the hypothesis, which could be found from the question. and then we compute the test statistics, find the critical value or values from the appropriate table, and finally make a decision and conclusion. We will discuss each steps in detail by looking at an example. Okay, so in this example, you are a marketing executive for a fast food company and you have asked 9 people, so your sample size is 9. Okay, so we start with step 0, identifying the sample size. If the sample size is less than 26, then we will be using the table J. Okay, so our sample size is 9, which is less than 26, and we will be using table J to find our critical value later on. So you have asked 9 people to rate a new pizza on a 6-point scale. Number 1 being terrible, number 4 is good, and 6 is excellent. The sample ratings are as shown below, and these are your data. At the 0.05 level, is there evidence that the median rating is at least 4 or good? So we have identified the sample size, and now we would go to the first step, which is to state the hypothesis. Identification of the claim comes from the question itself. Okay, so you are asked to find evidence whether the median rating is at least 4. At least means greater or equals to 4. So if we have the equal sign over here, as we have discussed in our hypothesis testing videos, this goes to the null hypothesis. So median greater or equals to 4 would be the null hypothesis, and the alternative hypothesis would be median is less than 4. Moving on to step number 2, we would now calculate test statistics. So step number 2 is divided into step 2a, where we would determine each sign value for the data, and step 2b, where we would determine the test statistics. So how do we determine the sign value for each data? We would compare each data with the conjectured median. So 4 over here would be our conjectured median in this example. If the data value is larger than the conjectured median, we would replace it with a positive sign. If it's smaller than the conjectured median, we replace it with a negative sign. And if the data is equal to the conjectured median, we replace it with 0. So 6 is greater than 4, we replace it with a positive sign. 2 is less than 4, so we replace it with a negative sign. 5 is greater than 4, positive. 3 is less than 4, so negative. 4 is equals to 4, we would replace it with a 0. 1 is less than 4, negative. 4 is equals to 4, 0. 6 is greater than 4, so positive sign. And 5 is also greater than 4, so positive sign. To determine the test statistics, or X, we look for the smaller number of either the positive or negative sign. So how many positive signs are there? We have 1, 2, 3, 4. 4 positive signs. We have 1, 2, 3 negative signs, and in total we have 7 positive and negative signs. So our test statistic X would be the smaller value of either 4 or 3 over here, and it would definitely be 3. Okay, so our test statistics is equals to 3. And now moving on to step number 3, we would look for the critical value from table J, and we are using table J because the sample size 9 is less than 26. Okay, the critical value will be determined based on alpha and the alternative hypothesis. So our alpha is 0.05 and the alternative hypothesis is less than 4. Less than 4 is a one-tailed test. We have discussed this in hypothesis test in our previous video. So we have one-tailed test and alpha is 0.05, which is the one over here in yellow. Okay, we will focus on the yellow column over here. Okay, and next we will look for N. N is simply the total number of positive and negative signs, which was 7. We have determined this before. And look, N equals to 7 is not even in this table. The table started with N equals to 8. The critical value was 0, 0, and 1. Okay, so for N less than 8, the critical value would be equals to 0. Okay, when N is less than 8, the critical value is equals to 0. So we have our critical value. We would now make a decision. The test statistic 3 is definitely greater than the critical value 0. So 3 is greater than 0. We would fail to reject the null hypothesis. Alright, so the conclusion would be that the median is greater or equals to 4. For the conclusion part, we would simply answer this question over here. Is there evidence that the median rating is at least 4? Yes, there is evidence that the median rating is at least 4. Moving on to the next example. This is a past year final exam question. It says the following data represent the number of hours that the rechargeable vacuum cleaner operates before a recharge is required. Test the hypothesis at the 0.05 level. So this would be our alpha. That this vacuum cleaner operates with a median of 1.8 before requiring a recharge. Okay, we would start with step 0, identifying the sample size. So what is our sample size? We have how many data? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data. Okay, so our sample size is less than 26. We would be using table J for the critical value. And let's move on to the first step, stating the hypothesis, the identification of the claim. So over here, we would simply identify the claim from the question itself. We were supposed to test whether the vacuum cleaner operates with a median of 1.8. That means our null hypothesis would be equals to 1.8 or not 1.8. So not equals to 1.8. Okay, so the equal sign always belongs to the null hypothesis. The unequal sign always belongs to the alternative hypothesis. Once we have identified the claim, we could now compute the test statistics. So we would compare each data with the conjectured median. Our sign value would be over here. Okay, 1.7 is less than 1.8, so we would replace this with a negative sign. 2.2 is greater than 1.8, so this would be positive. 0.8 less than 1.8, this is negative. 1.8 is equals to 1.8, so this would be 0. 1.5 is less than, so this would be negative. 2.1 is greater than 1.8. 1.6 is negative. 1.6 negative. 2.1 would be greater than, so positive. 1.1 is less than negative, and similarly 1.7 is less than 1.8. In total, we have 3 positive signs, 7 negative signs, and the total positive and negative signs is 10. So the test statistic would be the smaller value of the positive or negative sign. It would, in this case, be equals to 3. And moving on to step number 3, finding the critical value, which is based on the alpha and the alternative hypothesis. Now, the alternative hypothesis has the unequal sign, which means that we now have a two-tailed test. We would look at alpha when it is two-tailed over here. Alpha is 0.05. So our critical value would be somewhere along this yellow column. Okay. We would have to look for n, the total number of positive and negative signs, and our n is equals to 10. Okay, so n is equals to 10. Our critical value would be 1. Okay, so based on step number 2, we had our test statistic as 0. And step number 3, we had our critical value of CV as 1. Test statistic 3 is definitely greater than our critical value 1. So we would not reject the null hypothesis. Okay, the median is equals to 1.8. So let's answer the question over here. Test the hypothesis at alpha 0.05 that this vacuum cleaner operates with a median of 1.8 before requiring a recharge. So yes, the vacuum cleaner operates with a median of 1.8 before requiring a recharge. Now let's look at another example. The median age of Malaysian residents is 43.2 years. A researcher selects a sample of 50 Malaysian residents. So the sample size would be 50 over here, where NS is equals to 50. Okay, a sample of 50 Malaysian residents, and finds that 21 residents are older than 43.2. The rest are younger than 43.2. At alpha 0.01, this is our alpha. Test the claim that the median age of the residents is 43.2 years old. So by just looking at the claim over here, our null hypothesis would be that the median age is 43.2 years, and the alternative would be not equals to 43.2 years. So again, we have a two-tailed test over here. Okay, our conjectured median would be 43.2, and we have 21 residents who are older than 43.2. That means we would replace a positive sign for 21 out of 50 residents. So over here, that would be 21. And the rest are younger than 43.2 years old. In total, we have 50 residents. Okay, so 50 minus 21 would be 29. In this case, when the sample size is larger than 26, our test statistic would be Z, because we will be using the normal distribution. But anyways, we still need to determine X, which is the smaller number of either the positive or negative sign. And over here, our X would be 21. The N is 50. In this case, N would be the sample size. Okay, the sample size is 50. And to calculate the test statistic, or Z star, we simply take X 21 plus 0.5 minus 50 over 2 divided by square root of 50 over 2. Using my calculator, I get the test statistic as negative 0.9899. So our alpha is 0.01. To find the critical value, we would be using our normal distribution table, which is based on alpha and the alternative. Because the alternative hypothesis contains the unequal sign, we would have a two-tailed test. So this is similar to the hypothesis test that we have conducted for our parametric test. Okay, now our alpha 0.01 will be divided by 2. So over here, this would be alpha over 2, which is 0.005. And over here, alpha over 2 is also 0.005. Okay, to determine our critical values, so we would have two critical values. We will look at the left rejection region. So alpha is 0.005, probability is 0.005. It is closest to either 0.0049 or 0.0051. Okay, so our Z, or the first critical value, the critical value on the left hand side would be negative 2.57 or negative 2.58. Negative 2.57. And because for the standard normal distribution, our mean is equals to 0. This critical value over here would be 2.57. Okay, we have our rejection regions over here, negative and positive 2.57. The test statistic which we calculated just now was negative 0.9899. Okay, so negative 0.9899 falls outside the rejection region. It falls somewhere over here, and this is 0. Okay, and so we would not reject the null hypothesis. Okay, so we could conclude that the median is equals to 43.2. Let's answer the question. So at alpha 0.01, test the claim that the median age of the residents is 43.2 years old. Okay, our conclusion would be that the median age of the residents is indeed 43.2. Let's try out a simple quiz. So the question is, why does table J, the critical values for the sign test, stops at n equals to 25? Let's look at table J again. Okay, so indeed our table J stops at n equals to 25. Why is this so? Okay, the answer could be identified from step 0 over here. When the sample size is greater or equals to 26, we would already use the normal distribution table. We only need the table J when the sample size is less than 26. Okay everyone, thanks for watching, and I will see you in the next video.